Welcome to the May 2019 meeting of the Houston.net Users Group. You're welcome to join us in person for pizza, prizes, and networking on the second Thursday of every month. Our meetings are hosted by Improving Houston in their office at 10111 Richmond Avenue, just inside the Beltway in Houston's West Chase District. You can check us out for meeting notifications at HDNUG, on Facebook, or on LinkedIn. And now, a word from our sponsor, Headspring.
All right, Headspring. Headspring, we believe there's a better way. Delivering great software that transforms organizations through high-end consulting services and industry-shaping thought leadership. We have a lot of areas of expertise all across the industries, all across the board, whatever's needed. Our difference is that we have three uniques. We make your mission our mission, we win with speed, and we find a better way together. Why Headspring? We've got everything. Look us up, headspring.com.
And now our featured speaker, Garo Yeriazarian, will talk to us about the 12-factor app. Get your software cloud ready.
This is 12-factor app with the flavor of .NET. I'm Garo, Yeriazarian. I'm a principal consultant at Headspring. A little bit about me. Born and raised in Houston. Houston's my thing. I love Houston. That mural is at a delicious little gelato place in the Heights area called Gelazzi. Super tasty. Also has Italian food. So there you go. I went to University of Houston, got 2 degrees there. I like to do a lot of stuff there and really participate and help, contribute back to the school that really, I think a lot of us went to in Houston. .NET is pretty much where I spent most of my programming time. C#, .NET, web development, other things. And I just really, for me, it's kind of like a really comfortable place to do programming, very high productivity, lots of benefit, and I like it. Docker. I started to look into Docker a while back, maybe 3 years ago. And as soon as I really understood it, I really enjoyed it. I love it. It's such a powerful concept. There's so much you can do with it. It's cross-platform. All the .NET stuff works on it. It's something that everyone who's doing development today needs to learn about, needs to read up on, and get good at, because everything you do in the cloud, or even not in the cloud, Docker is going to help you do that better, because it's going to push you into a series of patterns that might be related to 12 factors that can get you into a more productive application. I spent 14 years working for Baker Hughes, which became Baker Hughes, a GE company, in oil and gas software. And then for the last year and some change, I've been working at Headspring as a principal consultant. And it's been really great working with clients, solving their problems, and jumping into their CIO offices and yelling, "Surprise, it's Agile!" So what's all this thing? Software is hard. Modern software development is tough. There's a lot of stuff going on. There's a lot of complexity. There's a lot of things you need to be aware of. There's a lot more things you can do. The expectations are much higher. The size of the data you have to deal with is bigger. And there's lots of advice out there on how to do it right. Everyone has an opinion. Everyone has a framework. Everyone has a set of guidance. Everyone has a tool that's going to be the one. 12-factor app is one of those sets of guidance. I think it's pretty good. It has a pretty solid backing. It came from the folks at Heroku, who looked at a bunch of cloud applications that were being developed and really tried to derive some common factors out of it. Are these the only 12 factors? No. It's as foundation, a starting point. It's a lot of things to think about. So .NET Core, for me, is a lot of the stuff comes out of the box. Now, JavaScript, Python, Ruby, all these other. Everyone has a flavor that fits into 12-factor app. But for me, .NET Core, plus it's also the .NET Users Group, so it kind of makes sense. .NET Core gives you a lot of benefit, and also helps you to get started quicker in really nice tooling in Visual Studio and be productive. So, software development is hard. This code I like. First 80% of software development is the easy part. The hard part is the next 80%. So, you're never really done, right? Software development is a continuous journey, right? Anyone that says, we're code complete, it's done, you're not complete, right? You still have the next 80% to go. You haven't even touched the surface. Software today needs to be portable, right? So we're looking at, it needs to run, let's say, just .NET applications, right? There's 3 kind of core platforms. These are unifying finally, like the news from last week, right? .NET 5 on the horizon. It's going to combine these 3 .NET platforms into one platform, and that's where everything's going to be based on. So we'll combine these together.
When's it due?
What is it?
When's 5 due?
When it's done. Well, so .NET Core 3 GA is this year, and then 5 will be sometime next year, I believe. They're already starting the previews of it.
They announced 2020.
2020? Okay. So pretty close then.
Yeah, I think the announcement just came out today.
Okay, so I actually put a date on it. Cool. Cloud providers, Google Cloud, Azure, AWS. You get different processor architectures. You got stuff running on Intel processors, AMD, more or less the same, but also ARM. You're seeing things that run on Raspberry Pis. They have to run on ARM64 servers, which are great for high-density, low-power applications, industrial applications. You've got to run on Mac OS sometimes. You've got to run on Linux. You've got to run on Windows. You've got to run in Docker. You've got to run in Cloud Foundry. There's all these different environments your app has to run. You want to make sure that your code is portable and your code doesn't depend explicitly entirely on one of these aspects. And 12-factor will help you to solve some of these problems. Configuration. You've got, let's say, 4 environments running in the middle, and you've got all these different configuration bits you have to run as part of that, right? Your connection strings, your secrets, your feature flags, your settings, your URLs, all your bits and pieces that you customize each environment. And so you've got a multitude of combinations that you have to deal with, and all goes in your application. As you go into different environments, all these configurations have to be managed, and your system has to be able to handle all the different situations you're going to throw it into. And maintainability. So traditionally, you have big bang deployment, right? Everybody, all hands, let's go. We're going to start to deploy this application, and it's going to take a day to deploy it. And we're going to do it once a quarter. If we're lucky, maybe there's some pain in there. But modern practice, DevOps, so hot right now. Because we're looking at bringing deployments down to hourly. We're looking at bringing deployments down to a lot more than hourly. Deployment should be an easy task to do, right? And that's going to be a requirement of modern workloads. Downtime is something that customers don't expect anymore. Right? If you give them a maintenance window and say the app is going to be down for 30 minutes on Tuesday, they're going to say, no, it's not. It's going to be up because Tuesday is my favorite day. So we have to find a way to work around it. So 12-factor app will solve all your problems, right? www.silverbullet.io. That's where it is. But will it? No, it won't. It will not solve all your problems. It's a methodology. It's practices, 12 of them, right? Hence the 12-factor. It's based on practical experience. A lot of experience, a lot of people going into it. And when you think about it, it's reasonable, right? Each of the factors you think about, you're like, okay, that sounds reasonable. And how it helps you out, too. The key terms that 12-factor uses is the idea of software erosion, right? Over time, your software wears away. All the different yes buts you have to do to it, and the different customizations you have to do to it over the years that you're using the software. There's all these things that happen to it. And at the end of its life cycle, it's unrecognizable from when it started because of all the database patches and the one-off things that had to be done, the small features that were added, the compatibility shims. It is interesting what happens to software over time. And this will steer you into the happy path of success, or the happy pit of success, whichever you want to call it. .NET Core, if you've never heard of .NET Core, it's pretty neat. It's cross-platform, so it runs on Linux, Windows, Mac, all the processor architectures. It's consistent across these architectures, so the same code runs on all the environments exactly the same. Not exactly the same. Okay, so let me correct myself, because I ran into some fun problems with time. If it has to do with time zones, it does not run the same everywhere. But everything else does, so it's good. So as long as you don't care about specific time zone issues, then you're okay. But otherwise, just test, just to make sure. Command line tooling. So all the rage is everything runs on the command line. I don't have to install a big tool to run it. I can do everything from the command line to creating new projects, to running it, to building it. Other tools. .NET Core has a bunch of extra stuff that's on the command line. It's compatible. It's compatible across all the main .NET areas. So you may have heard of Net Standard 2.0, where if you have .NET code that runs on Net Standard 2.0, it's guaranteed to run on full .NET Framework, .NET Core 2, 2.1, 2.2, and run on Mono. And it'll run the same in all these environments. And this is important because you don't want to have to write a bunch of if-defs in all your code to say, well, if I'm in this environment, I have this. If I'm in this environment, I want this. You want it to run the same because it's easier to test, it's easier to run. It's open source, free as in, let's see, it is free as in speech, and as in beer, and it's supported by Microsoft, and they're working on it actively. And C#, yum, C#.
Question, where, at this stage of its life, where wouldn't you use .NET Core?
Right now, the one place I wouldn't use it today is on embedded systems. Mono on embedded Linux has much better operating system integration than .NET Core does. But .NET Core is really targeting your cloud deployment right now. There's a really great article by Microsoft which talks about .NET Core 3 and .NET 5 and how this all fits together. And so full framework .NET is not really necessary anymore. Like it's an operating system components and that stuff there. Anything that's going into the cloud, .NET Core is the place to be. If it's going into a mobile app, then Xamarin and Mono. And if it's going into embedded Linux, then Mono does a much better job of letting you work with the embedded operating system a lot better. When .NET 5 comes out, then you'll have one that takes care of everything. Good question. So, any questions so far? This is just lead up to the 12 factors. Easy so far. Cool. 12 factors. Boom. No? Go back?
No, I'm kidding.
So, 12 factors, and I'll talk about each one. Are these the only 12 factors you have to worry about? No. These are just 12 factors that are guidelines, right? They're more like guidelines, actually. And why do you care? Because you need to start with a solid foundation, right? If you can think about how your application fits into all of these different categories and how it fulfills these, you're going to have a better time in integrating your application in the cloud. So Codebase. Codebase is your one true code base, right? Your one true code base that rules over all of your environments and takes care of everything, right? It is the thing that guides and controls all of the kings of your environments. And the reason this is important because you don't want to have, well, this is my dev code base, this is my other code base, and my other code base. And when I fix a bug, I want to fix it in one place, and I want it to be fixed everywhere, right? I don't want to have to fix it in here, and here, and here. So what happens is you want to be able to have one code base that at startup, you put your environment into it, you configure it, you customize the services, you customize the pipeline, whatever you need for that environment to function, whatever's different about that environment is based on the same foundational code. Your development workstation, this lovely piece right here, this is also going to be a deployment. This is an environment. It has to run on a developer laptop. It has to run on a server. It has to run on the cloud. .NET Core with ASP.NET Core web applications lets you customize how this starts up, the pipeline it goes through, and you can decide how things get subbed in and out. You can, when you study the ASP.NET Core pipeline, there's a request lifecycle, and you can plug into any stage of that cycle, customize it, and you can customize it differently for an environment. If you have a production environment that needs extra auditing on everything, you can turn that on. If you want to have logging that goes somewhere else, you can turn it on. If you want to have authentication that happens against one account for a developer system, you can do that as well. So it's all about customizing the environment for your needs and also for your deployment, but always from the same code base so that you have some semblance of sanity when there's one code base around. The second one is dependencies. So you want to explicitly declare and isolate your dependencies. So the way to do that is you download all the stuff from the internet, you stick it in a library folder, you set up references, and you put hint path on everything, and then you profit. Right? Am I the only one doing that? No. That's the old way. No, we don't do that anymore. What we do today is NuGet. NuGet is the way to load data, to load libraries into your system. And NPM as well for your web applications, right? NuGet, what is it? 152,000 packages. Every single open source package out there for .NET is hosted in NuGet. NuGet's also used to pull in parts of .NET Framework into your application and lets you have compatibility across other systems. When you look at a package you download from here, it'll ask you, it'll basically have a little selector for which environment you're in. Are you Net Standard 20? Are you running Net Core? Are you running Net Framework? So if there's any compatibility issues across processor architecture, across framework level, then it will pick the right DLL to point to automatically in your project. And what that looks like for you is like this. This is your project file. And you just include a package. You say what package you want, what version you want, and that's it. When you build, it will pick the right DLL to reference into your project. And you'll no longer have to deal with hint paths and picking your processor architecture and all of that nonsense that we've had to deal with in the past with full framework. And in Visual Studio, you just click and pick what you want. Yeah.
Public NuGet, private NuGet.
Good question. So public NuGet, private NuGet. A lot of the build tools today, actually all the build tools today, will let you host a NuGet feed. So your internal system, if you have a multi-solution product, and you have a big product, or you have shared libraries, you want something private where you can put your packages privately, have a core team work on, or actually the same team, actually, you want slice teams preferably, to work on shared infrastructure libraries and have it be published to an internal feed, and then you reference it that way. So what you're not doing is you're not putting DLLs on a network share and referencing them from Visual Studio. Don't do it. Instead, use the tools that you have. And there's a bunch of stuff on there. So NuGet.org is the place to be for figuring out how to use NuGet. It's in Visual Studio. .NET Core points you in this direction. As soon as you start to use it, it says this is how you're going to do things. And it's a lovely time. So this is important because if you think about all the different variations you have to deal with, your dependencies are important. The right version of the file. So you know that in this one, I'm always going to use version 2.04. I tested on this version. This is the version that builds. This is the version that runs. This is the version that gets deployed. Right? The only time that version changes is when I go in and I change it explicitly and say, I'm ready to upgrade. I upgrade, I run my tests, make sure everything still works, and I continue.
If you leave version out, will it just take the latest?
If you leave version out, in some cases it's expected, but in most cases it won't let you do it. It wants a version number. There are some special references that are SDK driven. That are SDK references. So ASP.NET Core, when you target a particular version of target framework, then there's certain libraries that are part of .NET Core that will pull in specific versions based on your target framework. So if it's if you're targeting .NET Core App 2.2 and 2.1, then you can have a build for 2.2. It'll pull in the 2.2 version of libraries. If you do 2.1, it'll pull the 2.1 version of libraries. And if you pick a version on those, it'll yell at you that no, you're not supposed to do that. But there's only very special cases in which that works. Configuration. So we talked a bit about configuration. Configuration should be in the environment, not in the code. Right? Your code should not include your connection strings. Your code should not include your secrets, your passwords, anything like that, because it hits your source control, and guess what? It's remembered forever. Because your source control remembers everything. So instead, we need a way to store our configuration in an environment so that we can get to it in a neutral way, update it, and look at it. Luckily, there's a really good solution for this. Boom. That's right. The best way to store configuration on your systems, right? Cross-platform? No? Why do you look at me like that? Registry is... Oh, come on. All right. We won't do registry. Okay, we'll do it a different way. The different way is this. Microsoft Extensions configuration is a proper modern library for configuration management. You can run this on full framework, and you can run it on net core. The cool thing is this is me setting it up, and these are all the different, some of the variations you can do. You can have configuration that's part of a in-memory dictionary. You can have configuration that's from a JSON file that gets reloaded automatically. It can be from an XML file. You can use an INI file if you got one. You can have it pulled from a database. You can have it pulled from the environment variables. You can have it pulled from the command line. At the end of the day, it takes all this and forms effectively a JSON blob of some sort, right? It's an object tree, an object graph that gets created as part of your configuration. You can also pull things from Azure Key Vault. You can pull secrets out of AWS System Manager. You can pull secrets out of some other tool that you want. It's all just configuration that you add in there. But when you consume the configuration, it's exactly the same way. This is a really slick library, and I really like it. I've been using it on some cloud applications and mixing stuff that comes from a file with environment variables, and it's delicious. Yes.
What if you have the same configuration settings in multiple files that you reference in this doohickey mababa?
Good question. So if you have multiple configuration settings that are in multiple files, it will process them in that order of precedence. So whatever you put first, gets pulled first, and whatever you pull next overrides what you had before. So in this case, all of your file stuff happens first, then your environment variables, and your command line can override all of that. And so whatever order you put at startup, that's the order that it overrides things.
Not cascading, just
Exactly.
positional.
Exactly. So, and there's a lot of neat ways to consume this too inside your code. And I have another slide on that in a bit. But this configuration is such an important part of it because you can include files. You could actually, some of the defaults is actually per environment. You'll pick an environment variable that decides, am I development, staging, production? And you can have it pick a different file based on that. So you have a base file that gives you all your configurations. You add a second file that includes your customizations. And then you can inject it.
Override.
Exactly, it overrides what you had before. So if you put in the right order, the overrides happen later down the line.
So the command line overrides all of them?
Exactly. So the command line will override, in this configuration, command line is last. It'll override whatever else you have.
What if I put command line first?
Then command line will not override everything else you have. It'll happen first. Now, it's not very helpful because someone will put something on the command line thinking they're making a difference, but they're not because the file takes precedence. So there's not a baked-in precedence. It's the order you put into here. That's the order that it processes. Any other questions about this part? All right. Backing services. So backing service is pretty much anything that you use that's not your application. It could be a database. It could be an email service. It could be a social media. It could be an authentication system. It could be a queue. It could be whatever. When you boil down to it, it's a URL and a little bit of configuration. It tells you how to connect to it. So your connection string is your URL, which is your host name for your database provider. And then you've got your authentication part. These are attached resources. They may not always be there. So what you need to be able to do is be flexible and be able to test that something exists and have a way to work around it too if you need to. So if it's not there, you need to find a way to fail. Right? Your application still continues to run. Maybe the database goes down for a little bit, comes back up. It may not always be there. Things may be local. They may be running on the same machine, or it may be remote. It may be in a cloud provider or maybe in a data center. But for your application, it's just a URL, and it's some configuration that tells you how to connect to it. So keep that in mind, because this detachment will help you. Now, in configuration, you can put the connection strings, you can put the email servers with the secret passwords, you can put API keys, and you can put it into a little class. Let's see if I can point here. I've done this one before. Anyway, I'm going to point with my fingers. So, you make a class that looks like your config file, and at startup, you'll configure it and tell it to bind to that section. And now when you inject, you can inject a option snapshot, and it'll inject it into your controller, into your service, and you can pull that configuration information.
How many different other options besides startup and inject?
So, well, this happens at start. So when you start your application, you're
Oh,
configuring.
never mind, that was a comment.
Oh, okay. Sorry.
Silly me.
At startup, you're configuring everything that you want to extract from your configuration. Now, if some of these are set to reload, instead of option snapshot, you can use option monitor.
We're trapped.
I know, right? Option monitor will let you actually listen for changes happening to the configuration and react to them. A lot of times, though, this configuration is per ASP.NET request, and so snapshot is going to be the easier way to go, because you really shouldn't be looking at configuration changes that happen in the context of a web request. Let the request finish, and then do the next one. But the powerful thing here is that as you customize your configuration, you can then abstract away the parts and pull it into classes and treat it as a strongly typed configuration. And so you don't care where it comes from. Yes?
If you make changes in the configuration file, do you have to reload the app domain?
No, you don't. So when you start, here, let's go back. I'll show you. So there's a nice little tidbit over here called reload on change. And so when reload on change is true, it'll watch that file. And when that file changes, it'll reload that layer of the configuration and apply it back in the order on top of it. So anything that overrode it later will still override it. But it will pull new values from that file if it changed. So you can have a file that gets injected or updated and change your configuration on the fly and manipulate.
But that's still positional within your program. If you looked at something at startup and changed it, it's not going back to startup.
Yes, that's where the difference between option snapshot and option monitor happens. But, so imagine, if you will, a web request, right? HTTP get that thing over there. First thing that happens is I create a new context, and I take a snapshot of my configuration. I've got a new database transaction. I have any services that are scoped. Then those all start up. And then my web request processes, and when that web request is done, the whole mess gets disposed, right? My transaction is closed, my scoped services get disposed, and that context goes away until the next request is new and fresh. So within that request, that configuration is static within that request. It doesn't have to be. See, if you have a long-running service, you can watch the options with options monitor and look for the changes that are going on there, and adapt to it if you need to.
Is that expensive? Performance?
Depends on how much teardown, and it depends on what it costs you to change configuration. If it's a database connection, then it's not going to cost you much, because your context, a new context is created and a new connection string starts when your web request starts. So at that point, it doesn't cost you anything. But if you have some other service that has an uptime, or not uptime, but a startup cost, then yes, it may take some time to spin that change back up. A good question. I mean, this is, in normal operation, you're going to find these kind of things that you have to worry about for sure. The other thing you can do is health checks. So ASP.NET Core 2.2 has a really cool health check feature. And there's an open source library that provides, so ASP.NET Core gives you the first one and a little bit of generic one. Everything else is provided by an open source library that gives you all of these other health checks. And so if you're running in AWS, you can have a health check that makes sure that you can access your S3 bucket, that you can access certain resources. You can have something that talks to identity server to make sure you can still authenticate. You can have a URL check that says, are these services still alive? Is my database working? Is my event store working? Is there certain things that are going on with my system resources that I need to be aware of? My disk space and so on. And all this gets collapsed into a single endpoint that's called health. And there's a lot of other plugins you can use to see more into it. Now, that's a whole nother talk of what you can do with health check. But there's definitely ASP.NET Core health checks. There's a huge amount of stuff you can do with it. And also, in modern systems, you have this idea of readiness and reachability and readiness, and word I'm forgetting, but it's a really important word, but not so much that I remembered it. This can tell you if your system's ready to take a request, right? Can I talk to my database? Can I authenticate? Can I store anything? Or if there's some variation of that that's not quite working, you can use this to figure out if I can get to it or not. What's the last time I checked it if I can get to it?
Is it- oh.
Yep.
So if you're just really anal, this is great.
Yeah.
Okay.
If you're connecting to all those things at once, though, I'm worried about you.
Me too.
That's a lot.
Oh, cool.
But this was really cool when I started using it. It's pretty easy to get into, and it ends up looking very simple when you have your startup. You look like you have a question.
Yeah, the Kafka.
Yes.
Like Kafka.
The
connectors,
message queue
Yeah.
is
Kafka
my
connectors is not like at a very ready state in the .NET ecosystem. I'm just wondering if you are actually working with Kafka.
I personally am not, but we do have teams that are. And we do have some projects that are message-based that are using Kafka. In this case, it's just seeing if it's awake. It's like, is it there or is it not? If I send a message, will it go through or am I going to get a problem? So health check is really about, is it reachable or is it not reachable? That was the other word, reachable. And readiness. Sure. Build, release, and run. So this is really simple. Your code builds binaries. Your binaries get injected with configuration and get released into an environment. Your same code should always build the same binaries all the time, regardless of where that's going. But your configuration is what makes it target an environment. So your compilation step should always be the same. It should always build a generic set of binaries. It should always be simple and easy. If you're using a system like Azure DevOps, previously known as VSTS, previously known as TFS, all that nonsense, it forces you into this direction. And at first I was a little bit frustrated because I was like, well, what if I want to do this? They're like, no. You have source code, your source code builds a product. You can then merge those products into a release and put them somewhere. But each source code set should build a set of binaries to keep it flowing well. The concern is that if you have too much complexity in your build process, too much customization, then you have to know, how did you build this particular binary? Did I build it with a certain set of flags? Did I build it with a certain setting? Did I build it with a certain option that maybe precludes me from putting it into a certain environment? And that makes it more complicated. So instead, in release, you use the configuration factor to throw in files, to throw in environment variables, command line arguments, and use that to customize it rather than using your build process to customize it. Any questions about that? It's a really tricky way to think about it, because traditionally what we're used to doing is that we build, it builds everything and it deploys, right? One go, top to bottom. You know, that's like, if I'm in Visual Studio, I compile everything and I hit publish, it's gone. But no one does that anymore. We do systems that help build Azure DevOps, TeamCity, Jenkins, all these systems and pipelines so that you have a process and a flow. So if something breaks at compilation, it only breaks compilation. If something breaks at release, now you know that compilation's good, release is bad. And help isolate where the problem is. Processes. All right, so this is number 6. We're almost there, halfway through. Processes are stateless and share nothing. Now, what's interesting about this is that last month we learned all about Akka. And Akka is everything is stateful, and you share things with message passing. So the complexity of the problem you're solving depends on the solution you're going to use. So there's some problems that make sense to have a highly parallelized stateful system, and some problems that make more sense to have a simple stateless process-based architecture. Most of the time, this is your default. This is the easy way to start. This is going to get you to something that's running, and then you evaluate if I got it right or not. If I need to go into something that's a different way of doing things, if I need to go into an Akka, but this will get you there first. The way this works is that your database, your cache, your authentication system, all these external things have state, but your web application does not maintain state. Each request happens, and you work with your cache and your database to provide a response, and that request goes away and has no lasting impact. What that lets you do is scale out instead of having to scale up. So instead of either building bigger and bigger servers or requesting bigger and bigger compute, you're going to have more instances of your app running on smaller grade compute resources. And they can be spread out across availability zones, spread out across different areas, spread out across your network, so that you can have more throughput. What's your number one slow factor in a web application? It's the network. It's I/O. It's your processing of your request happens really quickly, but you're going to wait for that disk to spin up and give you a record, that database to work, that even getting stuff from a cache that's outside of your system, there's still a network request that goes and gets that cache. So you're waiting. And what does waiting do? And you wait faster on a bigger system? Not really. But when it's a wider system, yeah, more higher processor.
You can wait more.
I can wait more. I can wait faster, stronger, better. I can wait for days. But spread it across lightweight resources, and you can process more requests in parallel. You need to have more throughput, add a third one. More throughput, add a fourth one. As long as your database and your stateful systems can handle all the variation, it'll work. So when you used old school ASP web forms, session state's turned on, all the stateful stuff is turned on, view state's turned on. There's all this stuff that it's remembering about everything you're doing. The modern ASP.NET Core default stateless. No session state, no remembering. The most you get is a little HTTP cookie, so you can track that session. And that's pretty much it.
HEOS. There's your state.
Exactly. HTML as a state. Was it HTML as the EOS?
Engine of application state.
That's the one. You can hate the OS. Fight the system. Port binding. So everything is a network service we just talked about, right? Your database, all your pieces. Your application is also a service. So guess what? We'll just, my app's running. It exposes an HTTP server. And I'm just going to connect to the internet. Easy. Easy. So simple. Nostradamus says no. That's definitely not the way to do it. The internet is a dirty, dirty, scary place. I'm running an application for a client, and I'm just watching the logs of things that just kind of start poking at your network. And there's a bunch of things looking for certain PHP files and certain vulnerabilities and so on. I had another client that thought it was a great idea. So they had a system they wanted to have remotely accessible. And it was at a remote well site, and they're like, you know what, we got to put it out there remotely, and I need to be able to get into it because it's so easy. So they took their cellular modem, and they took their computer, and they just plugged it in. And so your computer now has a IP address on the internet. That was a terrible idea. So they were wondering why their cellular modem fees went up, because apparently there were some of those Unix compatibility services running on this particular machine. And someone decided to probe at those ports and was running the echo service nonstop on a cell modem connection and jacking up their bill for cellular modem. So don't ever put your application directly on the internet. Instead, use a component that knows what it's doing on the internet, right? There's a bunch of different proxy servers out there, load balancers, tools that will protect your application. Nginx, IIS, Apache, cloud services. All the cloud providers have load balancers, they have firewalls, they have all of the delicious protections around protecting you from the dirty, nasty internet that's out there. And it's super easy to do. If you're hosting inside of a cloud system, you just click and turn this on. Right? If I'm running Azure and I run app service, I have some level of protection. If I'm AWS and I'm running Elastic Beanstalk, or out of the load balancer, I have some level of protection against all the things going around, because only one port's exposed, and that's the one port I'm using. Versus if I take my laptop and I put it on the internet directly, there's a bunch of stuff running on here. And I'm pretty sure I didn't get all the firewall rules right, and I'm sure something's going to poke through, and it's not going to be happy time for me. Yes, sir.
So you mentioned with like load balancers that it basically just singles it down to one area of attack that people could probe at. Do you see Bastion hosts still being kind of used as that like single vector?
So questions about load balancers they reduce the attack surface into one thing, and bastion hosts, are they still used? And the answer is yes. Sometimes you need to get into your application and do some like little command line goodies and some admin tasks. And so what you do is you open up a little pinhole into the cloud, and you limit it to this IP address right here that's coming out of this Wi-Fi card, and you open up that one port 22, and you make sure it's a public key exchange and there's no password, and then you use it. And once you're done, you just put some painter's tape over that, just like your webcam, and you walk away. And you're protected from everything. If the port's not open, you can't get to it. So the less stuff you have open on the internet, the less likely you are to have a problem with something attacking it. And less likely you are to face weird issues that are going on. Right. Any questions about that? All right. The process model. So we talked a little bit about this before too. Scaling up is adding more processes and different types of tasks. Being able to parallelize your different parts of your application by adding more processes to handle the load. Use load balancers in between to do work distribution and figure out who's going to take care of the work at that time. I like Docker to do this. I love Docker to do this because Docker lets you have the same port exposed on your containers, and you let your load balancer figure out where the work goes and do the mapping across. So you don't have to say, I've only got 32,000 ports of usable space, and I have to pick a unique port for every single one of my parts of my application. Instead, what you do is you expose the port, the same port you're always going to use, let Docker do the mapping for you inside of your virtual network. I'm not going to talk all about Docker, and I'm going to have some links at the end that's going to help you out. But Docker will help you with this. With your .NET Core applications running inside here, all you do is you expose the same port, and then your load balancer can figure out where the work goes and route the work based on what you need. That's a very generic way to talk about it. But the way to think about it is, can your application be parallelized in this way, right? And how do you take advantage of your operating system and your distribution system to do this work for you instead of you having to do it yourself? This is a problem that's been solved in a lot of different ways. Go ahead and use a solution that's out there. Make it easy on yourself. Disposability. The key to this is fast startup, graceful shutdown. The way you do this in .NET is you learn to implement disposable properly. Please, 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 please. Please implement iDisposable properly. There's a link that tells you exactly what you need to do. It talks about all the different use cases in which you dispose, because the way that this works is that your web request, like I said, it brings things up and it disposes everything that's disposable to cleanly tear everything back down. And that's the way to handle it. The garbage collector is going to do his best effort. So you want to make sure that when things can be explicitly disposed, to clear up resources and to make your application go into a clean state faster, that's the way to do it.
Can you go back one second?
Yeah. Sir.
You mentioned implement. Shouldn't you use it too?
You don't need to use it. Most of your applications and services, what you're going to do is you're going to inject them into your service, right? So the way that you want to use disposable services is you let the system do it for you. So in your constructor, you say, I need this, I need my database context, I need this, I need this, I need the socket, I need this, and I need this. Those get injected. The container, the ASP.NET Core runtime, will create those for you, scope them to your web request. You use them deliciously as much as you want. Once that response goes out or something errors out completely, all that gets disposed automatically for you. So using it correctly is taking advantage of the injection container that's already there that does the job for you. Don't explicitly go in and pull it and try to manage your own scope. Let ASP.NET Core do the work, because that's what it's there for. Easier, right? Best developers are the lazy ones. I love it. Dev and prod parity. Make sure all the environments are the same, because sometimes you get these kind of phrases that come up that there's issues in this environment. I can't reproduce the bug. It works on my machine. It works on my machine. It works on my server. It works on my data center. It works in my distribution environment. it all has the same concern, right? You can bring things up really quickly and easily. I can go to my buddy Docker, and I can bring up my entire prod environment on my laptop. I can have one file that defines how all these things are interconnected, and I can spin up an entire environment, test something, tear it down. I can go to my cloud provider and say, I need to create some temporary resources here, spin them up, use them for an hour, even if I want to use like a higher end compute node if I want, use it for an hour, tear it down, send the bill to my boss. And then he asked me why I used it, but it's okay. It's okay. But the idea is that the tools exist today to make this a lot easier, to make your environments easier to reproduce, easier to spin up. There's no excuse not to use the same things you're using in your production is the same as the staging and test and dev and on your developer laptop. Use the same tools to get you the same results, be able to debug what you're doing everywhere. And that's just not just for .NET. I mean, it's for everything. What is it? MySQL, database, Redis. What is Redis written in? Some scripting. Is it some more weird language? Was it Erlang? Or some nonsense? I think it's Erlang.
Well, I don't think Redis is written in Erlang. I know RabbitMQ is written in Erlang.
Yes, that's the one.
I'm not sure what Redis is written in. Probably some crazy language like Java or something.
It's probably COBOL. It's probably COBOL. I knew we were going to come back to COBOL. So it's written in Fox Flip.
Fox Pro.
Flip. What was that? What did we just talk about today?
Fox Pro.
Fox Pro?
No, definitely not Fox Pro.
Oh,
Nothing's written in Fox Pro.
Something.
You made the slide.
I know.
Oh my gosh. We're doomed.
I can't remember back then.
So long ago. Anyway, even if you have one of those, you can put it in a container. If it runs on Linux, or it runs on Windows, it runs in a container. Let the tools do the work for you. The goal is continuous deployment. So because our time between deploys is now going to be hours, because the people who are writing the code are the ones helping to run it in production, and because the environments need to be as similar as possible, that's going to get us into modern application development. Now comes my favorite one, my logs. All right. This to me is a game changer. Logging today is way different than it used to be back in my day. In my time, we used to log things of, hey, this thing happened, or log audit test 1, test 2, and if test 2 shows up, I know that this bug was hit, and test 3 shows up, something else happened. Logs should be the event streams of your application. So think about all the things that a to-do list will do, right? Each of these should be a log statement that happens in your logs, right? Now, where do your logs go? Your logs need to go somewhere, right? They don't just stick on a disk and they're gone forever. You have to feed them into another system. And that's what modern systems do. Now, the logs can be as simple as one-liners, right? So if I go in and I write my log error, I expected at least 1,000 foo bars, but I got this many. What I want my log to look like is not that one line of text. I want my log to be something like this. I can get some more detail out of this, right? I want to be able to say, I want to be able to parse this. I want to be able to query this. This is JSON. This is easy. And I want my log system to take this. So if you use Seralog, which is a library for logging in .NET, and you tell it to output stuff in JSON, you get all this context for free. Now this is a subset of the context. You get a request ID that's unique to each ASP.NET request. You get other contextual information about your HTTP call, and you get to, if you use a request ID, you can link together everything that was in that call altogether. There's another tool you can use that goes with this, that you can pull more information of this properties based on the objects you pass in this message. So another cool thing is that this message here that I passed, it doesn't have the value embedded in it. So if I wanted to search for every time this message hit in my source code, now I can actually go in and search for it. I could search for that exact string, and I could compare the values that I got and do some analytics against it. I could go in and see how many times this foobar error comes up, and I can figure out how many times did it come up when my foobars were close enough to 1,000. They were in the 900s, and I want to know that because it's important. I can run queries against that. There's other tools for log management. Each cloud provider has their own inbuilt tool. App Insights for Azure, CloudWatch for AWS, and then you can also roll your own, like an ELK stack or EFK stack, which is elastic Logstash Kibana or Elastic. What is it?
Or no, was it? It's like
EFK is it?
Beat. No.
ePulse.
Yeah, there was something that was added to Elk. Now it's called Elasticsearch.
Yeah.
So you just inject.
What was that?
When you inject the particular.
So what you have is you have a way for those logs to be collected. So if I'm running in Docker, I'm logging the standard output. All those standard output logs are collected. If I'm logging in a Linux system, everything goes into varlog messages. And so you've got a way for that to get pulled out. If I'm in Windows, I can log to the event log and throw a bunch of stuff in there and have something that someone, no, you don't want to do that? That's probably bad. Throw it into a file that then the file gets pulled out somehow. Yeah. Just put it in the registry, it's fine. Logging is, yeah. So.
As binary.
As binary, oh my gosh. There we go. It's a
Reg binary.
binary serializer into the registry for $1,000, Bob. That's terrible.
That's awesome coding right there.
I know, right? You've done it too, haven't you? I know I have too. The last one is admin processes. So if you have this system set up, you have administrative tasks that run, right? Don't embed them into your application, right? You've got a bunch of libraries you've created, all your helper stuff and everything that run your web interface. Take those same helper libraries and make a little console app that does your one-shot thing. If you need to go in and clean up, let's say we've got our illustrious to-do list, you need to clean up all of the ancient to-do items on a schedule. You don't have to set up Hangfire in your application to do it, to make it run in the background. Just make a secondary process that goes into your database and clears it out, using your same EF core context, using your same helper libraries and classes running alongside. So when you have administrative tasks, think about making them separate executables, deploy them together. And that's 12. So what I've got at the end is really just some links, right? There's so much in here. There's not one way to handle it. There's not one way to run a 12-factor. There's a lot of helpful places to go. These are links that I found useful in thinking about this and putting it together. And these are all starting points. There's some more recent, so I've got that disposable link here because you need that. Serolog and how to use it. Docker, very important. ASP.NET Core has a huge amount of tutorials. If you've never used ASP.NET Core, there's so much great stuff in there. And there's a little tidbit I put in here, Azure Dev Spaces, which you can read on the stuff. Questions at all? A lot to think about. A lot of stuff. So like I said, it's not the only 12 factors. It's 12 factors that could help you. It's a foundational point. Right? It's a starting point, somewhere to think about to help you build better software. So you can always reach me at garo@headspring.com. I'm on LinkedIn. I have a Twitter account. I don't use it. That's pretty much it. Cool. If there's any questions, thank you very much. Or reach me in. Thanks.
Thank you for joining us for this presentation of the Houston.NET Users Group. Our meetings are on the second Thursday of every month at the Improving Houston office at 10111 Richmond Avenue. Be there at 6:30 as we kick things off with pizza and prizes. If you happen to be in Houston on any second Thursday of the month, we'd love for you to join us.